Hello and welcome at our core protocol sync. Today we'll talk about what has our team achieved last week on the core protocol side and what we are planning to do next. And Shamil, maybe you want to start today?
Sure. I will share my screen first. Last week, I mostly worked with Kademlia and pieces publication, but before that, I fixed the last comments and merged APR for persistent record storage for the DSN. After that, I implemented different models for pieces publication using Kademlia. I needed to modify our DSN configuration because the default configuration won't work for push model because of message size. The error message from Kademlia wasn't so expressive, let's say, and it took some time to decipher it. But eventually, I was able to use push model for pieces in order to get our farmer syncing from the DSN for plotting the sectors. I started from implementing pool model using start providing method of the Kademlia, but encountered a weird issue. It ended up in some kind of queue for the inbound substreams. It's kind of strange, and there is a discussion on the lib2p repo, and I raised a bug report, created a bug report for that. I will probably discuss it with them tomorrow. But using the push model, I was able to make the DSN become a source for plotting for farmers, and I successfully saw that it works as from the DSN. Also, I changed a little bit different aspect of DSN configuration, like I disabled filtering for them for pieces on the Kademlian side, but I will restore it when we will fix this issue, this start providing method of the Kademlia. For this week, I started implementing pieces retrieval from sectors, like from the cold storage. I managed to edit just cancellation for piece retrieval process for farmers, just convenience feature. I reworked multi-hash creation for different use cases and started implementing announcing pieces by sector on the farmer's side. So that's it. Questions?
Can you elaborate a little bit on the issue with providing and peer-to-peer,
Sure.
what it looks like?
I created some kind of loop for announcing pieces using start providing methods. It should just announce on the network that some peer contain the data. And it looks like that peers on the DSN acquire some kind of queue for the inbound streams, but without any processing of those streams. So for the first 32 requests, it goes okay, because 32 is a hard-coded constant for the substream, for substreams in the transport layer. But after that, it started to issue warnings that substream was dropped. And it's really strange, because other queries, for example, get to closest peers, I can send hundreds per second without any issues. Or let's say this push model, which is much heavier request, which is put value with the whole piece in the DSN, it works okay with no issues. And the interface for start providing doesn't seem to have some acknowledging method. So you have
you tried to print something from the registry and see if it even tries to add something eventually on the receiving
Yes,
side?
it does for several pieces for the first 32 substreams. I tried to switch to the latest version of the VP2P because we now are using the version similar to the substrate, and it doesn't work. So it's not about the version. The latest
It
version
doesn't work,
is
or maybe it's just slow. Is it possible?
actually, this is a good command because I tried to introduce some pause between requests. I started from 700 milliseconds, no changes. I increased it to 3 seconds, basically, no changes. And when I increased to 17 seconds, I believe it start to work, but it's not what we
It's
want. 17
ridiculous.
seconds
Okay.
between requests, and it doesn't make sense because similar queries works with no issues. For example, get closest peers 100 per second, no problems. Also, much heavier queries like put value. It's the same query but with data attached. No
I see.
issues. Multiple per second. So it's very weird. And I found the similar discussion on the libp2p forum, but they said that basically we will mm, this issue could go away by itself because we are moving to different back pressure model for requests. However, I'm not sure that it will fix it because they also commented that it will just improve the interface but won't solve the inner issue. So I created a bug report with all the debug information, and I want to talk with them on the community
Okay.
call.
Makes sense. Okay.
This
I'm
is
glad
why
that
that
we have
PR
figured it
created
out.
is draft, and we could
Sure.
discuss it later how to review it.
Okay. I'm glad that we have figured it out already, and we are waiting for response rather than figuring out at last moment.
No,
Okay.
I created that on Thursday.
Okay. Can you post the link into the engineering chat so I can follow it? Or is it mentioned
Yes,
in the
but it
pull
is
request?
attached to the PR and
Okay.
you as a viewer.
I will
But
go
I
from
can
there.
do that, no problem. I can copy that.
No, I will go from pull request. Thanks. Any other questions?
Nope.
All right. Lu Cheng, what was happening on your side?
Yeah, regarding the changes on the core protocol side, one is that, okay, it's this reorganization for the domain-related queries, like basically like those domain-related queries. It's not like more obvious. It's like related to the domains, like no more like series, no more cumulus or domains, like all domain. The another thing is that after the discussion with Gemma, we so firstly we found some issues after merging the receipt into the bundle due to the parent receipt check in the transaction pool. And after some discussion with Gemma, we decided that we simply drop that check in the transaction pool for now, and we'll leave all of those logic into the state processing, specifically for the block execution. So there are some subtle nuances caused by this change. I need some more time to think about it before I can share it. So it's a work in progress. I'm still testing this locally to process the receipts more properly without checking the parent receipt in the transaction pool. Yeah, I think that's the main thing on the core protocol.
So I guess the main drawback of not having that check is that you can potentially have receipts that were already included, so you're just wasting block time.
So I think without this
checking,
it's just some inefficiency was introduced without checking those earlier. Otherwise, we are fine. It's not like strictly necessary.
Yeah, I mean, if you include more receipts than necessary, then you are just wasting space in the block, right?
Yes, that's what I mean in efficiency regarding the
Sure.
block space.
I'm wondering if you can charge executors for that space if it's like redundant. So
We are.
that would,
Yeah, that's not specified yet, but that is the plan, is basically executors are paying for this on behalf of the users and then they're deducting it from users. That's the long-term domains pricing model. We just haven't really specified that at the implementation level yet. And the other part of this is that the actual inclusion of the receipt is not the long-term plane either. It's just going to be the hash of the receipt. And there's going to be like a challenge to return the receipt. So it's really just a hash that we might be including. The bundles are expected to be different. So it makes sense like at the current stage, but like in the long term, it's kind of like we're going to optimize for something that we're eventually going to drop. So it's not worth.
okay, makes sense.
Yeah, that's main updates on the core protocol side.
Okay. Ivan, I guess you didn't have any updates this time, right?
Yeah, right. Yeah, just reviewing code. Yeah.
Okay. On my side, I think the only change is the benches. I can share the results very quickly. I think we went through the general code changes last time. And Jeremiah asked to have the results of those benches attached to the issue so we can have like a baseline. And can you see it? Okay. So the results are the following. The plotting process is basically the bottleneck at this point. If you are using just one core on my machine, it does about 10 megabytes per second, depending on the run. And when I'm using all of the cores, which I have 12 and 24 threads, it doesn't actually scale linearly. It kind of scales linearly within the number of physical cores, but not logical. So it looks like some internal CPU instructions are more limiting than just I/O. The audit is quite fast. We can audit with one core 100,000 elements per second, which means sectors. And if our sector is big enough, that means a lot of space. And if you are using more cores and correspondingly more parallelism on different disks, we can achieve even more. So that doesn't seem to be a concern. On the proving side, we can also prove quite a few hundred elements, like meaning sectors per second. It's unlikely that you will have 400 solutions for every time slot, so that's also not a concern. This is the only concern, but we are in the process of redesigning this, so it will work differently and hopefully much faster. But this is the baseline we have so far, and there are some specs of what I have on my machine. Yeah, I was trying to run bigger benches with slightly different parameters by increasing the space L parameter in the consensus and also the piece size to simulate chunks which are 16 sectors which are 16 gigabytes in size. It basically takes roughly forever to plot, meaning like one sector is a day or something like that. I will not wait for a day to create one sector just to test how audit works on that. It's clearly not going to work. So that's the stage so far. With the upcoming updates to the consensus, we will be benching it again and again, and we will be able to see if you are progressing in the right direction. Beyond that, there was no code changes this time on my side. And for this week, we'll be having discussions with Jeremiah and will be more changes. Before that, I will be working with Shamil to agree on the interface and to provide the interface from the farmer, such that these plotted sectors can be actually read by the like DSN adapter, and we can expose those sectors and pieces for other farmers to plot from. And that will be like the first version of the actual DSN powered subspace, I think. Yeah, that's it on my side. Any questions?
Yeah, just a comment about the plotting. Thanks for those benches and going over them, Nazar. On the plotting throughput, we've always kind of had a rough ballpark estimate of 10 to 15 megabytes per second per core was the goal, to achieve like 1 terabyte in 24 hours with a quad core machine, which is kind of the baseline user experience we're looking for. So even though, I guess just to contextualize that sounds slow, 10 megabytes per second. Certainly machines could plot, can write to disk much faster than that, but that's part of the security, is it's supposed to be slow as well. So that's probably actually within the ballpark of what we're looking for. But it is going to change for sure with the new upgrades, where it's going to be more erasure coding that we're effectively doing, and some polynomial commitments as part of the plotting process.
Yeah, I think I also should add that the slow part in all of that is actually chunking the sector in 20 bits and XOR those 20 bits with the key. So I think if you write some special purpose code instead of using a library, we can actually optimize it maybe by 10, 20x. Folks like from Supranational, they are really amazing at that. Yeah, but this is the baseline. Okay, anything else we need to share before we close out today?
Well, it's still me.
Oh, sorry. Go ahead. I thought you already shared.
No, I didn't. I mean, did very little detail in the last meeting. So the last findings that I had from work, I was working on our sort of custom way that we could commit to commitments, because the thing is that in KZG you cannot do it normal way, and other schemes are doing either. So for example, you have a big sector and you can commit to smaller things like pieces, but you want to have some root commitment that commits to everything, like in the Merkle tree, for instance. So a few ways that it's usually done is either you commit to hashes of commitments, or you just take all the commitments and you hash them together and you call that a root. But in this both cases, you're going to have provide to all the commitments, so that it has drawbacks. And I was trying to invent a way to leverage the fact that the commitments are elliptic curve points and you can actually do polynomials on them. But I'm still seeing an issue because you cannot really divide those polynomials, and it seems to be crucial for KZG, so I'm a little stuck. But I was able to commit to a polynomial of commitments, and I have a code that does that, so that's cool. So there actually might be something there. And I was able to spend some time finally to disentangle what Ethereum is doing with their 2D KZG scheme when they are extend erasure coding data both in rows and columns. And the biggest finding is that other schemes that are doing it, like erasure code proof system scheme or polygon avail, they are doing erasure code in one direction by doing one polynomial, as Reed-Solomon does. Then they derive another polynomials in columns and commit to those. Ethereum is going to be using one big double variate polynomial for both. So they actually have a polynomial in two variables, in x, y, and then the value is going to be both in x and y, and a chunk that was quite a find. So I'm still writing it down in my review of what other schemes are doing.
Does that mean that polynomial is quadratic in size or something?
Yes, so when they erasure code, they evaluate, they quadruple the data. Basically, they do not double it. They double it in both directions, so it's quadruple. So that's And when they do data availability sampling, they are not sampling as every single chunk. They are sampling like batches of whatever 16 or 32 of those. And they have pre-computed proofs for every batch in that square. But we're talking about like 4 to 5 megabyte sizes. So it's not really that lot of data. But that's, well, it's kind of completely different from all the other schemes that we've seen.
Okay, that's exciting, Derek. Thanks for the updates there. It's also cool. I saw you did the commit to your fork of semi-avid PR. So glad you got something working there. I did actually have one update about the concern we had about semi-avid PR. The fact that they are not interpolating when they do the erasure coding of the rows or of the commitments, but they're just taking those as exponents and evaluating. So there's actually a point in the paper where it says that it could be done with a systemic code, meaning that you could do interpolation and it would work the same way. My guess or my assumption is they probably did it that way because it gave better benchmark results for the paper to not have to interpolate. So that was part of one of the claims of the paper. It's the fastest method or highest throughput. But it does appear to work in that direction. It kind of makes sense logically. When I spent some time looking through the code this weekend, and it kind of makes sense that it could work that way. And it seems to actually be almost another instance of the same thing Vitalik is describing in that 2D DAS post, or like the simplified version of that. Seems to be roughly the same idea. It's just systemic codes versus non-systemic, which is what they implemented in semi-avid PR.
Yeah, I think, yes. It's just the thing that thing that Vitalik describes as 2D is not the 2D that the Ethereum goes with. So it's a little bit confusing there.
Yeah. Okay, great. Well, we can spend some time going through that in a bit more detail after this, but I just wanted to share that with the group. So I guess to translate that into what most of y'all will be able to understand, it looks like the scheme that we had originally thought about actually will work. Efficiency, like complexity, is still a concern, but at least theoretically, from a security point of view, it will work. But we still need to validate that, and that's probably what we're going to be implementing in the next iteration. Okay.
I'm just waiting for construction noise to finish so I can talk. I guess these are all updates this week, or is there anything else we need to share? Okay, thanks everyone for watching, and thanks everyone on our team for great work. We'll see you next week.